Welcome to this demonstrator video of the CAVIAR project. In this video we will show the technology development on a focus aid for broadcast video, which is being developed by TNO and Grass Valley. Nowadays the world is getting used to digital broadcasts of live sports events in very sharp 4K video quality. It is easy to forget just how much the resolution of broadcast video has increased over the years. Yet the viewfinder that the camera operator uses to view the scene has much fewer pixels. On the viewfinder display, it is very difficult to see the image quality of what is being recorded. When the subject is not well in focus, this is very hard to see on the viewfinder. In the first year of CAVIAR, we investigated the shortcomings of the current focus aid in the viewfinder. We demonstrated that it is not selective enough in showing what is in focus. In this example, we see that the image skateboard is not sharp in focus, yet the viewfinder overlay suggests that it is, by showing a bright overlay signal. Even when the focus is changed significantly, the signal does not change all that much. In the second year of CAVIAR, we've developed new solutions for this problem. We have developed several new algorithms that measure the local sharpness in the images. Two approaches were taken. On the one hand, we adopted a signal processing approach to create two algorithms based on Laplacian filtering and wavelet decomposition. On the other hand, we adopted a machine learning approach to train a neural network to provide a focus response behavior that we can freely specify. To test our solutions, we made a setup in which we imaged 3 different test scenes with different 3D spatial arrangements of test objects. In this test, we looked at the focus response of our solutions. For a good response, we would expect that we only get a high signal when the imaged subject is sharp, like in the middle image here, but not when the focus is before or after the subject. For a poor solution, the Q signal decreases only slowly as the subject moves out of focus. So let's see some results. In this visualization, you see the camera output at native resolution. To the right, there are 4 small images that show the focus signals computed with different methods. From top to bottom, the current focus assist solution in the camera, Laplacian filtering, wavelet decomposition, and the deep neural network method. These signals can be visualized on the viewfinder, for example using a colored overlay as is currently done. We will see that the currently used Q signal rises and falls more slowly as the scene moves into and out of focus than that of the new solutions. Next, let us look at another scene with more depth variation. Notice that in the current solution in the viewfinder, the chef and the text in the back are almost continuously highlighted. This becomes even more clear when zooming in on the chef and the bear. Let's look at when a camera operator would stop focusing because the current viewfinder Q nears its maximum value. Although the viewfinder overlay is saturated, the head of the bear is not quite sharp yet. Now consider the same task for one of the new solutions, in this case the one based on the wavelet decomposition. This time the camera operator would stop much closer to the optimal focus. To appreciate this, look for example at the unsharp reflection in the eye of the bear. Here for the current solution. Especially in a side-by-side comparison, it's clear to see that the new Q signal allows the camera operator to focus much more accurately and produce a sharper output image. Finally, let's look at the scene with a real test subject. Again, the new solutions are much more selective in when they highlight the subject to be sharp. For comparison, look at the Q signal here in this frame where the subject is in optimal focus. Notice that the new solutions exhibit a much sharper drop-off in Q signal over the course of 50 frames. So to conclude, we have developed new and more selective focus assist algorithms that enable camera operators to produce more sharply focused images and thus to get the full benefits out of the high pixel count of the camera. And finally, looking ahead at the next year of the project, we will work in parallel on realizing a real-time implementation of the signal processing based algorithms in the camera and increasing the robustness of the deep learning algorithm, such that it is available as a second stage in the improvement of the camera's focus assist function down the line. We hope that you've enjoyed this video and look forward to seeing you again for the final demonstrator of the CAVIAR project next year.